All right, I hope everybody's doing all right. This is Coach Lowe coming to you. We're going to celebrate the last 3 pages of these notes, 8.3. In style, we're going to be talking about the mean difference, and we're going to use a little bit of technology and throw in some crazy formula stuff. So here we go. When we have pair data, don't forget what pair data means. Okay, pair data means you have exactly the same amount of data for whatever criteria you're talking about. Okay, so you should see two different numbers for each whatever data what each criteria you're talking about. So we can calculate an interval that measures the difference in ability. Okay, so that's what we're going for right here, some difference in ability. Um, when you get down here, you're going to notice they're going to put in a subscript D, so that is going to be for the differences. Okay, so the true mean, which is going to be mu, because that's a true mean difference in ability. Down below this, these are the three that we normally get our hands on right here. You've got the observed mean difference, you've got the standard deviation of the differences, and then you got the number of the differences. Okay. Below that, we have the 95% confidence interval, and it's going to start with the mean difference, the observed mean difference, plus or minus 2. And don't forget where this 2 is coming from. On the bell-shaped curve, the empirical rule, um, the middle 95% is represented by being 2 standard deviations away from the mean. So when you see 95, that means you're going to have an automatic 2 right here. Okay? So we have the observed mean difference plus or minus 2 times. Then you have the standard deviation of differences on top, the numerator, divided by the square root of the number of differences. And we're going to put that to work on the next screen. So here we go. All right. Let's take a class and we're going to get some paired data. We're going to take all the students out here and they're going to throw a baseball and then throw a softball. Okay, so a class of 35 students. So I'm going to go ahead and start keeping track of what I know here. So this is going to be in. Um, Went to the football field. Each student threw a baseball and a softball. So you're going to have a baseball number and a softball number for each student. Therefore, you're going to have paired data. Okay. So the distance for each throw was recorded. The differences in distances, okay, baseball minus softball in that order, was calculated. The mean difference, so this is going to be our observed mean difference, and then was 5.5 yards with the standard deviation. So this is going to be the standard deviation of our differences, which would be 7 yards. Okay, so explain how we know this is paired data again. So let's come right here and say, hey, because we have exactly the same number of data for each criteria. Okay. In other words, you're going to have two numbers, baseball and softball, for each student. Okay, so definitely pair data. All right, here we go. Calculate the 95% confidence interval for the mean difference in ability. I'm going to change this over to green. All right, so let's go to the formula. So the formula should go. We got our observed mean difference, whatever that is, plus or minus 95% confidence interval. So we're going to have a 2 right here times a fraction. On top is going to be the standard deviation of the differences, and on the bottom is going to be the square root of the number of students we have. Okay? All right, so let's plug all this in. All right, let's go back to the orange. I feel like Miami colors right here. So the mean difference would have been, where was it, 5.5? 5.5 plus minus 2, automatic because of the 95% confidence level. That's going to be times the fraction. Standard deviation of the differences was going to be 7 yards, so that's going to go up the top, and then over the square root of the number of people we had in this class, which was 35. Okay, so I went ahead and crunched this out. Please be careful doing it. Make sure you're abiding by the order of operations with that calculator. But let's see here, what did I get? When I crunched it out, I got the interval going from 3.134-ish to 7.866-ish. Okay, so I got lower boundary here, and I got the upper boundary there. All right. All right, here we go. Very important. Interpreting the confidence interval. So let's go back to the green. So here we go. Make sure you get the lingo here. Um, Very important how you write this. So we're going to start off with I am 95% confident. Okay. That the interval of plausible values, okay, from, now we're going to throw in our interval. So from lower boundary 3.134 to 7.866, okay, contains, so I'm 95% sure that that interval will contains what? So now you need to make sure you're throwing your context here. The true, and we've gone back to ability, then we did a true proportion. So since we're doing a mean difference here, let's throw in true mean difference of, and basically you're talking about the distances. So I'm just going to put students, distances. Okay. All right. So does this interval provide convincing evidence that the students have the ability to throw the baseball? All right. So tell you what, I'm going to write some of this up above it because I'm going to be squeezed for room here. So when I do this, I like to think about, of course, a number line. Um, if I'm looking at the lower boundary, upper boundary, 0 would be here. And then I'm going to throw in the lower boundary. I get there first, 3.134. And the upper boundary is going to be way further to the right, not, uh, okay. Okay. So, uh, zero's here. Your whole interval is going to be here. So here we go. Here's the question again. Does that interval provide you convincing evidence that students had the ability to throw the baseball further? So what you're going to say is, hey, since the interval is entirely positive, is all positive, let's do that. All positive, we have convincing evidence. We have convincing, got to write small down here, evidence that students threw baseball further. Threw baseball farther. Okay, so going back here and just elaborating again. If your interval is entirely to the right of 0, all positives, that means you have convincing evidence. If your interval is back here in some way where it straddled 0, you had some negatives, then you would not have convincing evidence. Okay, so if you're going to go to the ha, that means you got to have your entirely positive interval when you're talking about these differences. Okay, all right, that gets us through the rough stuff. So let's get on to the next page. So it's going to be more technology here. So talking to Coach Pritchard, I agree with her. When it comes to 95% confidence intervals, I think we're going to make our students do those out by hand. And for anything else that's like in between the 95, the 99.7, 68, such as, if you notice, they're going to bring in 87 right here. They hadn't done that. They're going to bring in 98. So for things like this, we're going to use technology. So get to use some new buttons here. So here we go. Question is, throughout the 39 games, 2010-11 season, Kevin Love of the Timberwolves led the NBA in rebounding. His average was 15.8 rebounds per game with a standard deviation of 5.16. All right, so over here to the side, they got directions for you. So what you're going to do is you're going to press the stat button. You're going to arrow over to the test, which we don't get too much, and you're going to scroll down to the T interval, which is option number 8, or you just hit 8. Okay, it'll get you there a little faster. And what's cool about this is you can do this from two different perspectives. Um, once you get to that T interval option, you got these two options right here. You got data, you got stats. If you're going for data, that means you can actually plug in raw data, which I did just today with some test scores. Okay. So if you put your raw data, like let's say here in list 1, you can come to data, make sure it's on data, make sure it's coming from the right list, whatever your confidence level is, and then calculate. And the other option is if you're doing stats. So if you're doing stats, it's going to be kind of like this problem with Kevin Love, where they're giving you the mean, they're giving you standard deviation. So you want to hit the stat button in that case. All right. But either way, it's going to shoot out an interval for you. It's kind of nice. So let's do these problems. So over here, I went ahead and snipped from the graphic calculator what you see. If you're going by the stats for these, which I guess you're going to have to, you would plug in the mean 15.8, standard deviation 5.16, 39 games. You're going to type in 87 for the confidence level, hit enter, and this is going to be your confidence interval, okay? And if you went for the 98% confidence interval with the same information, nothing's really going to change until you get to the confidence interval, so make sure you type in 0.98. And so you're going to get a different interval, okay? Very short and sweet right here. Hope you got something out of it. So that's it for now. All right, good luck, everybody.